kind of encapsulated in that. So, there's 3 of us in the office. We have 3 full-time employees. Luigi Romolo is the state climatologist. Pete Boulay is the longest serving member of our office. So many of you have probably worked with Pete over the years. And then I joined in 2015. And we all have kind of different roles, and we're non-hierarchical. So we actually all report to Joy Lockery in the water monitoring and surveys unit. And so a lot of what I do is help people understand, well, I kind of have 2 roles, really, 3, I guess. One is to just be a climatologist, which is a lot of kind of current events climatology. I write a lot of the stories that Pete ends up posting on our website about things that just happened. For example, over the weekend, we had an incredible burst of snow that appears to be one of the heaviest snow bursts in years and years in the Twin Cities area, and that was on Saturday night and Sunday morning. So, writing up those sorts of things. I also do, I manage a 40 weather station kind of climate observing network. It's called a Mesonet. And that just got off the ground a handful of years ago, and we're making improvements to it. But the idea is to have additional real-time or near real-time long-term monitoring. And then the thing that I probably get sort of seen the most for in the department is what we're going to talk about today, which is helping people understand what's going on with our climate. Our office does a lot of other things, and it does a lot of really neat things. So I really encourage you to get to know Pete and Luigi if you're not familiar with them. Lots of cool stuff. We got a great big web page that we've been operating for decades also. Okay, so today we're going to talk about how the hydroclimatic changes are affecting Minnesota, really what hydroclimatic changes we're observing. And then there's a lesser emphasis, because it's not my expertise, about how it impacts water resources in Minnesota. We are obviously, water resources are intimately and intricately connected to our climate. So we will begin. So a couple things to bear in mind, and sometimes if you've seen me talk about this, I often will have a whole list of things that you should really bear in mind when you're talking about the climate and climate change, but let's just keep it simple here. Minnesota is different. Our climate is different. If I asked you to, describe our winters, you'd probably say that they're snowy and cold, or cold and snowy, cold and long. And if I were to ask you to describe our summers, you would say that they're generally short, but sometimes very hot, humid, and stormy. And maybe you'd have different descriptors, but that's kind of a snapshot of our general climate. And when you consider the fact that not every winter is long and cold and snowy, sometimes it's kind of mild, and you almost wonder where winter went. And similarly, sometimes our summers are very long, sometimes they're dry, sometimes they're wet, sometimes they're really stormy. But those additional descriptions give you a sense of the variations around kind of our baseline climate that we expect. All right, so that's Minnesota. But what if we were doing this in California, or in say Florida, or any other part of the country that's not really in our region, and certainly many other parts of the world? We would have to use different descriptions. We can't say that, California's winters are long and cold, snowy. I mean, there are certain parts of the state that get snow and cold, but I mean, that doesn't fit the description of California as a whole. And I don't think that most of us could go to kind of, whether it's the Central Valley or the Northern California or Southern California, and really recognize our summers in their summer experiences. So big differences. So our climate story is different just by virtue of geography. And so as our climate has changed, we also have kind of a different set of symptoms from other places, again, in the country and also in the world. And so I always like to point that out, because it's easy to get lost in the news and all the reports that are released and all the information that you get bombarded with that you might not actually have time to read. about what's happening to our climate. And sometimes it's hard to find Minnesota in there. So that's a big part of my job, is helping you find Minnesota in this story of globally changing climate. And then something that is kind of a key feature of Minnesota's climate is something we just described, which are these huge variations, these kind of variations, not just from one part of the year to another, but from year to year, from even, multiple years at a time to another multi-year phase. We have all of these big variations. It's part of being in the middle of a continent where you're equal distance between a moisture source like the Gulf of Mexico and, say, a mountain range like the Rockies out west, or even the kind of near Arctic parts of central and northern Canada. They're all about the same distance from us. So they're all really just one wind shift away. And so it's not surprising then that our climate reflects all of those regions and their climates too. And whenever the wind blows predominantly from one area as opposed to the other areas, you kind of get more of that type of a climate. So we have these normal variations, but at the same time, we also have trends. And the fact that we know that, for example, we're getting warmer and we're getting wetter, which we'll talk about in a bit, that doesn't mean that we won't occasionally have variations away from those trends, like, cold winters like the one we've just had, or dry spells like the one we had in 2021. In fact, we can have variations, and we do have variations and trends simultaneously. They don't prove or disprove each other. You might think of it if you were driving out to, say, I don't know, Montana or Colorado from Minnesota, and say you're going into the mountains. Well, you know that on your drive, you're going to end up higher in terms of elevation than where you started. That's a given. We're going to start our journey, 600 or 800 feet above sea level, and we're going to end up 8 or 11 or 13,000 feet above sea level. But that doesn't mean the whole ride is just a straight line up, right? It's not just a ramp. You're actually going to go up and you're going to go down even along the way. You're going to go up again and you're going to go down. And this is the same thing we're doing with our climate. We are going up in terms of temperature and precipitation, but we will go down along the way. And so we can't confuse, short-term variations that are a normal part of our climate with longer-term trends. They don't disprove each other. They operate together. Let me give you an example. This is a graph I'm resurrecting that I used to show to kind of help make this point. This is just taking the upper Midwest, and I don't even know what region this really is. I think it's Minnesota, Iowa, and Wisconsin, and maybe Illinois, but it's this region called the upper Midwest. Take the average of their annual temperatures, and you can see it. Last time I updated, it was after 2017. It's not really, doesn't matter if this particular image isn't up to date. The point is, you can see each of those dots represents the average annual temperature around that region, and we're calling the upper Midwest, every year from 1895 through 2017. And you see, you can kind of, your eyes will show you a trend for sure, but you also see lots of ups and downs. Some of them are big and a lot of them are small within that trend. And you can also tell that the trend's probably not a perfectly straight line, but we're going to take a deeper look at this. The most common way to express a trend in climatology or in statistics is to use the ordinary least squares regression. It's just that simple. It's just like your basic geometric line from, junior high school or high school. And this is just based on the statistical distribution. It's simple and elegant. It's also prone to significant misinterpretation by both its champions and its dissenters. You really need to kind of pay attention to this. But in any case, you could see in this example, we've got a trend of 0.19 degrees Fahrenheit of temperature increase per decade. There seems to be more going on, though, than just that trend. So let's add in now. I think I've got here a nine-year moving average. So now we're taking every 9 years, or we just roll through. So every year we take a new average of that year in the most recent 8 years. So the 9-year moving average through it. And again, this is another kind of arbitrary metric. And the thing about a moving average is it moves over time. So it doesn't give you that nice, simple trend, with a temperature change per decade. But it also helps show you kind of a compromise between the two. You see that we are generally going up over time, but you can see that those ups, that upward trajectory is still characterized by and downs along the way up. And kind of like our ride out to, Colorado or Montana. We could also, if we look carefully at this, using, other statistical techniques, and we're not going to go into a deep dive of statistical techniques, but you could find even visually a place where this whole time series seems to kind of break apart and maybe has two different points. And it just so happens that using change point detection algorithms, most climate scientists have found there's an inflection point right around the year 1970, almost everywhere in the world. It's somewhere within a few years of that. So that's kind of been adopted now as the sort of break point that you look for. It might not be perfectly represented in regional or in Minnesota's climate, but we try and be kind of faithful to what the science says. And so look, if you break apart this temperature distribution over our larger region, you see that there's kind of two different modes, right? So at the beginning of that period, 1895 to 1969, you had what I would consider to be a much shallower temperature change, right? It doesn't matter what I consider. 0.12 is obviously a lot less, somewhat less than 0.19. And so there's a general linear temperature increase expressed here, but it's not as sharp as what we saw over the long term. So then what happens if we look at 1970 through, in this case, it's 2017, a much sharper rise in temperatures, over a half a degree Fahrenheit per decade. So when we talk about a trend, there are trends in our climate, it's not this singular thing. I mean, over time, our temperatures are increasing, that's for sure. You have to admit, though, that there are year-to-year variations along the way, and that even the trends themselves can be broken into more than just one part. So that you might look at an earlier phase and a later phase. And then even when we're in that later phase, where the temperatures are increasing rapidly, you still see plenty of years where the variations are driving the temperature below that trend line, below what would be sort of predicted by the trend alone. So it is completely normal to have, wild variations in our climate at the same time as a trend, which means there's nothing wrong with having a cold year or a cold winter during a time where you are telling people that there's incredible winter warming. They both can be true. They both are true, and one doesn't really violate the other. And then, of course, you can look at whether we look at the multi-year average like I did, or just something crude and visual like this. You can see lots of big variations along the way that you can kind of back through that entire distribution. So having big ups and downs does not mean that there's no trend. Also, having a big up doesn't prove that there is a trend. You kind of have to be careful in multiple ways here. So I like talking about that, give you kind of some grounding as we talk about trends. So what are the trends that we've observed? And sometimes, especially lately, I've been trying to suggest that maybe, statistically and in the scientific literature, we call them trends, but maybe it would be easier if we just called them tendency. Our climate has had a tendency to be warmer and wetter than it used to be. I don't know if that would actually help people kind of demystify this issue at all, but it's a tendency. So we've had this tendency to be wetter and warmer. This is a major shift that we've observed, and it's also projected to continue, which means that we don't just stay where we are at a warmer and wetter place than where we used to be, but that all of the models, virtually every model, tells us that we're going to be probably wetter, at least receiving more precipitation. It takes a little more, it's going to take a little more analysis to know if that means we're wetter because as temperatures rise, you've got increasing evapotranspiration and evaporation, and who knows where that makes you land with respect to the overall water budget. But in general, looks like we're getting more precipitation as we look ahead. And certainly, unless we get a massive volcanic eruption, every model expects temperatures to continue rising significantly, and in many cases more than we've already observed, especially as we get beyond the middle of the current century. One of the big changes that we've observed is shorter winters with less cold and more snowfall and less snow cover. So that's a lot. I just gave you a lot of nuance. Shorter winters with less cold, but more snowfall, but then less snow cover. We're going to see that this all fits together. We have had a rapid loss in cold extremes, and this is all projected to continue. Now, we could talk about this winter. We'll have plenty of time to do that in the other part of this presentation, but this has been a cold winter, but it isn't historically cold. If you look backwards at other years, this really isn't a noteworthy winter in any way, shape, or form in terms of cold. It's just that by today's standards, it's been pretty cold or even really cold. But you could go back several decades, and this would have actually been a fairly typical winter, not that unusual, even in far northern Minnesota. So that maybe gives you a sense of how these changes have occurred. What we now think of as really cold didn't used to be so. And then in the summertime, we haven't gotten hotter yet. Even when you throw 2021 into the mix, I'll show you that in a little bit here. But we have had fewer cool nights. And I think what a lot of folks we're going to spend a lot of time talking about this next piece, is that we've had more frequent and heavier downpours with more and larger big events. And all of that is also projected to continue. One change that isn't kind of in this list of what we've observed so far is that probably in the next couple decades, we don't know exactly when, we're going to start getting much hotter. We haven't done that yet, but there's a difference between what we've observed and what's projected by these models. So two main changes so far. We've been wetter and we've been warmer. Because sometimes I have to help people kind of cope with this, and it's good to point out for a number of reasons that Minnesota's climate is not worsening, in quotes, across the board. There are some things that are definitely getting harder to manage, like those increases in precipitation extremes. And of course, there's secondary impacts from all the warming that we've observed in winter. But so far, the heat extremes that we're observing in Minnesota are not out of the bounds of the historical behavior of heat events in Minnesota. In fact, they're well within the bounds. So we're not even really pushing the bounds. And that's, if you think about, if you can't find something in the literature that says definitively, here's how the climate is changing in this particular place, then you have to go to the data. And if you're going to the data, then you need to devise some tests that help you understand, okay, is this kind of unusual climatic behavior? Because if you're starting to see the climate do things that it never used to do, then you've got a decent argument that, well, maybe that's a part of the climate that's actually changing and is actually reacting to the globally increasing temperatures. And all we know is that right now, heat extremes in Minnesota have not shown any of that behavior. As a side note, we have seen their seasons expand a bit, but the total number of hot days or the severity of hot days really has not been going up, not over a recent term or intermediate term, and certainly not over the long term in Minnesota. Drought got everyone's attention. We'll talk about that a little more because last year was a big year and we really hope not to repeat it. But it's not something that we've seen that through the literature or through the data are shown to be worsening in Minnesota. Now, we do see some opportunity for drought to get worse in Minnesota, at least when it occurs, but there's very little in the data or in the projections suggesting that we're going to have more frequent drought. This is mostly because everything points to more precipitation at this point. And, we could always be surprised, but you have to go by the data and the science. And right now the science points to more precipitation for our future. Also, tornadoes and severe convective storms definitely fall into the category of not necessarily worsening in our region, not becoming, more powerful or more numerous, but their season is also expanding. So, last year we had a massive severe weather outbreak in December, and that was just in 2021, and we just had a killer tornado event in Iowa, not unheard of in March, but this is kind of an expansion of the normal season, even though these particular phenomena don't appear to be getting worse by most metrics. Okay, so that's kind of so we're warmer, we're wetter, we've got warmer winters that don't get as cold as they used to be. We're getting more precipitation in general, including more extremes, but then heat extremes, drought, and the tornado and severe convective storms aren't. We don't have any evidence that these are becoming more numerous or worsening at this point in Minnesota. If we take a look at temperature and precipitation, just kind of combined into one little dot for each year. So we take Minnesota's average temperature and Minnesota's annual average precipitation total going back to 1895, and then we just plot it against 20th century averages. That's what you're seeing on the kind of middle of the graph, those axes there. So this is a two-way graph. We can't tell what year any particular dot is because we're just looking at temperature and precipitation averaged around the state. But by looking at where each dot is with respect to those axes, you know that in the upper right quadrant, those would be your warm and wet years, and in your lower left quadrant, those would be your cool and dry years. So temperature goes left to right, precipitation goes bottom to top. And what you see is a nice symmetrical distribution here. These are for the years 1895 through 1986. I started doing this back when it was 2000, I guess it was 2016 when I started showing this graph, and I wanted to then reveal the next 30 years so we'd have a kind of a climate normal period to compare. Now we have 35 years, but let's look at the difference between the symmetrical distribution that we saw 1895 through 1986, where there isn't any real tendency for a randomly selected year to be on one side of the axes combination or another, versus what we see when we add the most recent years. So again, we add to years 1987 through 2021, and you see this jump off to the right and also up. And interestingly, in the last several years, we've had this kind of tour of the extremes. So 2019 at the top there was actually a little bit cool, but was our wettest year on record in the state. 2016, just a few years earlier in the upper right, is our combined wettest and warmest year on record. And then you do see 2021, definitely not the warmest year on record on a statewide basis, but it's getting up there, and it was dry. And so you can see that we've kind of shifted generally into a warmer and also somewhat wetter regime. If we look at how we've gotten wetter, this map, you might have to kind of squint, but these are our climate normals. These are 30-year averages, and they're taken around the country. And so you can look at it on a national level and just see how the 30-year precipitation averages have changed going from the beginning of the 20th century to the most recent. It's always, climate normals always end on the most recent 0 year. So ours current normals period goes from 1991 to 2020. And you see it's not quite every new decade that we get a new normals gets wetter and wetter and wetter. There's some variation if you look closely in Minnesota kind of built in there, but the last few decades have just gotten wet like we have never seen before. And I'll just point out that I would be telling a very different story, and I'd have to have a whole different narrative and set of bullet points if I was doing the same talk in, say, Arizona. If you look at their trajectory, doesn't really match ours at all, or Florida. So just keep in mind, again, geography is kind of a determinant in the sense of how you tell the story of how your climate is changing. Here in the upper Midwest and in Minnesota, we have gotten a lot wetter. If you want to look at how our wetness has sort of just comparing, so we're just going to compare these last two panels here. The last two normals periods. What's the difference between the 1991 through 2020 normals for precipitation across the year in Minnesota versus the one previous to that, 1981 through 2010. And what you see is that on an annual average basis, of course, we increased our precipitation. We got wetter, but it wasn't every month. Basically, our spring and early growing season months have gotten wetter, April through July. And then the later growing season, August, September, and November, so later season and fall months have generally dried out a little bit. So the overall trajectory was wetter years, but but as you can see, it's not that every month has gotten wetter, and that certainly they haven't behaved in a uniform manner at all. Some of this might just be kind of, random occurrences, things that happened that were kind of big defining events, and some of these are actual signals that we're seeing. If you look at how our precipitation has changed, again, using that cut point at 1970, you see that up until 1969, we really didn't have a trend. We weren't getting wetter at all. We had a lot of variation. We had the dry period in the 1920s and 30s, and then we recovered from it. And between the two, though, there wasn't really any trend, especially since we'd gone from wet, then to the drought, and then back to somewhat wet again. But since that period, where we had kind of recovered to our normal, what seemed like our normal climatic state, we just kept getting wetter. That doesn't mean that we've been drought free, not at all. Look at that big spike down in 1976. There's you can find other low points in the 1988 and 89 in there. But we've had this trend towards wetter years where the average year, basically a typical years about 4/10 to almost, maybe 45/100 of an inch wetter on average by decade compared, going from 1970 through 2021. So that's an increase in annual precipitation. And this is, again, averaged around the state. So some areas get much more, but that's an increase in annual average precipitation of over 2 inches, 2 inches and small change. So it's a decent increase in precipitation. A lot of this has been driven in the southern parts of Minnesota. In say the Twin Cities, for example, one of the things we've seen is a greater proportion of our precipitation coming from these days where you get heavy precipitation, these days where you have at least an inch of precipitation. So the bars show how much of our total precipitation is coming from those days where you have at least 1 inch of precipitation falling. And you see that in the 2010s, we were the kind of greatest total amount of precipitation coming from 1 inch rainfall or precipitation days on record. And then those dots just show what's the proportion, the percentage of annual precipitation coming from days with 1 inch or more of precipitation. And that was also kind of at an all-time high. And we see this in lots of stations in Minnesota, especially in the eastern and southern parts of the state, parts of southwestern Minnesota also, and less so up in the far north and in the northwestern parts of the state. We have 38 historical stations in Minnesota. These all have at least 100 years of record. We can actually push all of these back to 1916, and they've got continuous records. Hopefully we can keep this network going, but we keep losing observers. So when I started doing this, I think we had 41 stations, but in the last 5-6 years, we've lost a few observers. In any case, what we can do is we can just look at the data that we have for each of these 38 stations and go back every year, say, well, what's the average of the largest daily rainfall at each of those 38 stations? So take the 38 station average of the wettest day of the year. And what is that amount? What is that average amount of precipitation on the wettest day of the year? And you can see that over time, look at the ups and downs along the way. Your eyes will kind of tell you the story yourself. And what you see is that, there's a lot of variation. And there's a lot of years that look the way they used to look. But now we also have in recent years, up in the upper kind of right quadrant, right corner there, you've had some years where that value, that average largest daily precipitation value around those 38 stations is much larger than anything we'd observed historically. And that's kind of driving this almost check mark appearance. So it's not that every year we're seeing bigger rains and more rains at all the stations. It's just that now with greater frequency, we are seeing that. It's happening, some years and more years than we ever had seen. And we could do the same thing if we take those same 38 stations and we ask, okay, what's just the largest precipitation event anywhere in the state? And you see that now on the right side of the graph, we occasionally get years, again, it's not every year, where the largest event in the state is much larger than anything we'd observed historically. I know that people like to talk about 100-year rainfalls, and usually when people do it, unfortunately, they're not quite doing it right. You can't just assume that there's some kind of dependency between a 100-year rainfall event in southeastern Minnesota and one up in northwestern Minnesota. But you could use the same network that we have, 38 station network. They've got a nice stable record, and just search at each station for events that exceed each station's 100-year threshold for 24-hour precipitation. And what you see using the NOAA Atlas 14 values is that beginning in the 1950s, we started seeing these events. And it's not that they're totally off the charts now. It's just that the interval in between 100-year events being measured somewhere in Minnesota is on average getting shorter. In other words, there is reason to believe or to say that we are seeing more 100-year precipitation events in Minnesota. The interval in between them is getting shorter, even when you use kind of a constrained network like what we have. And then you get these local anomalies, like what we saw at Redwood Falls, which, from this table that's kind of excerpted from NOAA Atlas 14, I don't assume that anyone really knows what we're looking at. But if we look at what's the 25-year daily rainfall value, it's 4 3/4 inches at Redwood Falls. And then look at this that happened in the mid and late 2010s. At the Redwood Falls Cooperative Station, every year except 2015 had a rainfall amount that exceeded the 25-year daily rainfall. Now, this is more like a local anomaly as opposed to something that's happening everywhere, but it's an example of what can happen when your hydroclimate gets kind of supercharged. And also, so getting 5 and 6 years is kind of a big deal. And then we also had an 8-inch rainfall there in 2017 that beats the 100-year value, actually beats the 200-year value at Redwood Falls. We're seeing more of these mega rains. Also, this is where you get a really large event in terms of quantity, but also in terms of aerial coverage. And so this example here from East Central Minnesota is we've got thousands of 2,000 or so square miles that exceed 6 inches of rainfall from this event. So this is what we call a mega event because usually it's 1,000 square miles is all. That's a very big event. These have also become more common so that in the most recent 22 years, we've had 11 mega rain events. So they're still rare, they're still uncommon, but they're just much more common than they were for the first 27 years of our record. So a shorter period, yet yielding us more than twice as many of these events. Obviously, maybe you've seen these before and afters, because you're not just dealing with rainfall totals, it's what happens to the water. Well, you get, soccer field that ends up getting inundated. And really, you can see, if you look closely at this image, you can actually see the water, it's almost like a whole river system that formed around that soccer field complex. You see the water goes as far as the eye can see there. Or in Duluth, the same event. This was in 2012. You have a before, this is Brewery Creek, and then after. And the idea isn't that this is happening everywhere, every year, of course. It's just that when you get into an enhanced hydroclimatic regime like this, you end up with more of those types of events. Our precipitation is projected to continue increasing. So this is just annual average precipitation showing basically that, by the middle of the century, we should expect changes that are similar to what we've already observed. So we'll get what we've already observed in terms of precipitation changes again in the next, what would that be, about 25 to 40 years or so. And also more heavy precipitation expected. This is kind of showing what's going to come of what we now consider to be a 98th percentile rainfall event, and basically something that now happens 1 to 2 days a year on average would be happening 2 to 3 days a year, which might sound like a small increase, but it's actually that's like a 50% increase in the frequency of those. We've also seen heavy snowfall increasing. So this is just the Twin Cities. The blue bars show the average seasonal snowfall, which was up there, not quite the highest, but it was pretty high in the 2010s. But then those dots show the annual average number of days with at least 4 inches of snow. And that we had more than any other time on record in the 2010s. And the same is true at other places. Now, when we look at how our temperatures have changed, I won't spend quite as much time on this, but you see the same kind of picture for Minnesota. Our temperatures have increased to levels that we really had never observed before in the last couple decades. And the distribution of our monthly temperature pattern actually resembles what we've observed so far this year. Basically, we've had this tendency to have colder springs, but then much warmer falls. That's kind of been where we've seen this. Now, it doesn't mean that that's what's happening every year, but that has been what sort of drove the increases in our temperature normals. And they weren't as pronounced, partially because we had some springtime conditions, late winter and spring conditions that were quite cool in Minnesota. There's a pattern of your annual average temperature increase. It kind of looks like what I showed you for the region, except this goes through 2021. Big change in 1970. That's kind of where we really started seeing the temperatures increase. And you may have seen this. This goes right through the 2021. I should have the annual average there, and I didn't. But it goes through 2021. The northern Minnesota increasing temperatures at a faster rate than southern Minnesota, but everywhere the annual temperatures are increasing. In the wintertime, when you take an average night in the wintertime, in northern Minnesota, it's over 7 degrees warmer than it was, and that's December, January, February. Typical night during that 3-month period is now 7 degrees warmer, even in International Falls, than it was at the beginning of the 20th century. Not quite as dramatic in southern Minnesota, but still about 5 degrees warmer on a typical winter night than it was, 100 some years ago. Summertime highs haven't shown the same kind of increase. In fact, in far southern Minnesota, there's a slight, it's not statistically significant, but it's a decrease over time. Our summers just haven't really, those summer days have not gotten much hotter. The main difference, the main exception here is northern Minnesota, where we are starting to see summertime highs increasing to levels that we really hadn't observed very frequently in the past. Central Minnesota, it's kind of a small upward trend, and that's over the long term. If you looked at the more recent, few decades, you'd actually see kind of a flat line. So mentioned this before, what we think of as cold now used to be pretty common. This is Milan out in western Minnesota. We just don't get as cold as we used to. We're looking at the lowest temperature of the year and the average of the lowest coldest 15 days of the year. And they both, with ups and downs, but they're both going up, and they've been going up. And so you could look, I think I've actually got this current. So this does represent 2022 here. Just wasn't that, it felt cold, but it wasn't that cold. If you look to the left, these kind of winters used to be really, really common. And you could take the closest spike downward in 2019, and you'll see that in 2019, we had a low of -33 in Milan. That's pretty cold, but again, if you look to the left, it used to be pretty common. So what we think of as cold now used to be pretty typical. What we used to think of as really cold doesn't really happen anymore. That leads you to this kind of behavior, where in the wintertime, snowfall's been generally up across most of Minnesota over the last several decades. So 2010s were the snowiest decade on record at Milan, which is one of our best observing stations in Minnesota. But during that same period when you get snow, between, say, November and March, we also had more thaw days during the 2010s than any other period on record. So more snow, but because it's been warmer, we're also having more thaws. And we're seeing things like this. Every station in Minnesota is seeing an increase in liquid precipitation during the winter months. So this would be December through January, average annual number of winter days with rain. You know, it's not a huge number anyway. We don't expect tons of winter rain, but it is more common than it used to be. And this leads you to declining snow depth statistics. So Duluth, this is just a great station over the last several decades, but we see this everywhere. There just isn't as much snow on the ground for as much time, period. We've lost a lot of our snow depth characteristics so that you spend the November through March period, the average snow depth is declined by 25, 30% or so. But then those individual lines showing that the number of days between November and March with 6 inches or 12 inches of snow on the ground are 25 and 35% less, respectively. And the number of days with no snow on the ground is up by about 60, 63%. So kind of a change in winter dynamics here. This is one of many ways of visualizing the duration of ice on lakes, but there's been a decrease. And depending on how you look at it, the Pollution Control Agency recently released a tool. They've got basically a loss of about 2 weeks of ice cover on a typical lake. Again, there's variability in there. There's ups and downs. We're going to have pretty average to late conditions most likely this year, but in general, it's been a long-term decline in the typical ice duration on Minnesota lakes. And then this is just to show you there's no obvious trend yet for the summer high temperatures. I mean, we do see 2021 was a pretty warm season. I've got it circled there. Very warm summer on a statewide basis, not the very hottest, but one of them. But what we don't see is some tendency for lots more of these types of summers. In fact, if you look at recent summers, just to the left of it, they're kind of clustered right around the historical middle. And this is the thing, we do not, even when we apply the 9-year moving average, there's just nothing right now that suggests our high temperatures during the summer are kind of leaving the historical distribution. And if we go back to Milan, that same station, and just look at the hottest temperature of the year, same thing. We just, even when we include 2021, which was very hot, it really doesn't stand out historically, whether you're looking at the hottest day or the average of the 15 hottest days of the summer. So the last thing I want to mention is that the drought this year got our attention for sure. And I'm not going to try and diminish its severity. It hit Minnesota very hard, and I think it hit us hard kind of emotionally. But one of the reasons we had a lot of challenge talking about this, because drought has this kind of forever feel to it. You're in a drought that hasn't rained in weeks, and it just feels like it's never going to end, in a way that some of these other trends haven't had that, because when you get warm winters, it's not that every day of every winter is warm, and it's just a tendency, right? But with drought, it's this kind of prolonged thing. And so we were getting a lot of questions about, well, is this climate change? Is this the face of climate change? Or are our droughts getting worse? And, there's a really nuanced answer to that, but the basics are this. When you look at the most recent, say 22 years on the top, back to 2000, as long as we've been doing the drought monitor, you don't really see any indication that these kind of big spikes with amplified drought monitor categories are becoming more frequent or worse or more, taking up more area in the state of Minnesota. In fact, you see that for a lot of the 2010s, we had no drought at all in Minnesota. There was not a lot of information indicating the drought's worsening, at least if you just look at the most recent 22 years. Now look at the bottom panel, and this is using the 9-month standard precipitation index, and you can see on the far right, that's our spike, the really severe and in some areas extreme, and in isolated areas, exceptional drought of 2021. And just look to the left. And what you see is this was not a standout event historically. It was bad, but it had also been a long time since we had dealt with this. And so it's probably safest to think of it as an expected deviation from what had been a predominant trend towards wet conditions. That's kind of how we make sense of the drought here. We knew eventually we were going to get hit by one, and we knew we were going to get hit by a doozy of one, and that we might not be ready for it. But the fact is that, you look into other parts of the 20th century, and drought was just much more common, much more widespread, and in many cases, much worse than what we had here in 2021. And that's, again, not to diminish the hardships that people felt. I think you have to kind of hold the truths in both hands, that it was a bad drought, and we've also really been lucky that we haven't had more like it or more that were even worse. The future of drought is pretty nuanced when we consult the science, because we do have very good information suggesting that with global temperatures rising, the reservoirs of warm air are only going to get more and more, they're going to get more prominent, they're going to get larger and deeper. And it's just going to be easier over time to get really high temperatures for possibly local and kind of regional climatic influence reasons. We haven't really experienced that yet. But as summer temperatures do start to rise, then there's this sense that even if drought remains kind of low frequency, those occasional drought episodes will start to get worse, because they'll be combined with higher temperatures than we're used to observing, and maybe even some high temperature episodes that kind of challenge some of the seemingly untouchable records that we have in the past. And then when you combine that with the fact that we are expecting more precipitation in the future, but it's kind of also expected to break into fewer events, leading you with maybe more days in between those events with longer consecutive dry spells. You kind of emerge with a really murky picture where there is some evidence that drought conditions will worsen in Minnesota when they occur, even though they will in general probably be less frequent than they were historically, or at least possibly. That's what's suggested by the science, that they'd be less common than they were historically, but they might also be as bad or worse than they were historically. But then this is all going to be sort of imposed over this general trend towards just being wetter, having more precipitation in general. So I know it's a lot to keep in mind, but I think as water resource specialists, it's kind of important to be able to think reflexively about something like drought that isn't just as simple as it gets dry, therefore things are worse, or drought getting worse in general. So in summary, the region's gotten wetter and warmer. This has been driven by more frequent heavy precipitation. That's the wetter. And also warmer winters. I mean, that's the big driver. Our nights have also gotten warmer, but the least warming has been during our summer, and especially our summertime days. The projections indicate that this is all going to continue, and then we're going to also add on some stuff. So the warm and cool and wet and dry variability is also going to continue. That's going to be part of our climate forever. So we're not going to get to a point where every year is just warmer than the year before. We're always going to have ups and downs. That's just a fixture. And what that means is that even as we get wetter, drought too, as part of those downward variations in our hydroclimate, will also remain a fixture. And then again, when you combine it with the fact that we haven't gotten hotter yet, but we do expect that by the middle of this century, then you can actually start to imagine some drought episodes that start kind of getting a little harder to manage than even what we've had recently. So that's it. Thanks for your patience during your after lunch hour, where a lot of people probably want to take a nap. So I appreciate it. Thank you.